So we're going to look at putting multipliers in front of parabolas. You need to know these two general forms of parabola before we start. If you can't do this reliably, then you need to go back and watch the previous video until you are 100% certain you can write the equation for a normal parabola. So we have two forms, the intercept form and the turning point form, where effectively it intercepts twice at the same point. If we put a multiplier in front of either of those two forms, that changes the steepness of the parabola. Doesn't move it left or right, just moves it more or less steep without changing the intercepts or the turning point. If the number we put in is less than 1, then it makes the parabola less steep. If the number is negative, then it flips the parabola. So let's have a look at how that works in practice. Here's a simple case, x minus 2, x minus 4, so the intercepts are at 2 and 4. If we stick a multiplier in front, in this case a 3 in front of the whole of the formula, then this is our new graph. And we can see that where it used to go down 1 to the turning point, it now goes down 3 times as far. It's effectively 3 times as steep. It has the same intercepts, the same basic shape, but it's 3 times as deep. Another one. Once more, we're going to look at x minus 2, x minus 4. This time we're going to stick a negative 2 in front of the whole thing. Well, the negative 2 flips it because it goes from a positive parabola to a negative parabola. Intercepts haven't changed, but whereas it was 1 away at the turning point, it is now 2 from the 2 part. So it has the same intercepts, the same shape, albeit more steep, but it's flipped and is 2 times as steep. So that's basically how it works all the time. If we put a half in front, then we get a broader, as it were, fatter parabola, still got the same intercepts, still got the same parabola shape, still symmetric and all the rest of it, but this time it's half as deep. Instead of being 1 down, it's half down. Well, we can use this in reverse to find the equations of simple parabolas when they have multipliers. And to do that, we compare the height at some point, which is almost always in fact the y-intercept or the turning point, with what it would be without the multiplier. To do this, you need to be able to sketch the equation of a graph of a parabola, or else none of this makes any sense. And then the multiplier is what it should be, divides what it actually is. So let's see how that works in practice. Here we have a parabola. It has intercepts of 0 and 4, so its equation is of this general form: y equals x, x minus 0, x minus 4. That's its general form. But if we look at x equals 2, which will be the turning point because it's halfway between the two intercepts, and put the 2 into that formula, we get 2 times 2 minus 4, which gives us minus 4. So that's not what we've got. We've got 6, not minus 4. So this is what the red dotted line is, what y equals x, x minus 4 actually looks like, and ours is a little bit deeper. In fact, it's gone from 4 to 6. So its equation is the 6 over the 4. What it is over what it would be in general form gives us 1.5. So that's the equation of the green line, y equals 1.5x, x minus 4. Now the equation this time with the other general form. So the general form of this is x plus 2 squared, where this plus 2 is minus minus 2, so the negative of minus 2. The intercept of that graph that is of this graph is 4, not the one we see, because when x is 0, 0 plus 2 squared is 4. So we would get this parabola if we sketch y equals x plus 2 squared. The intercept is 4, whereas our one is 1, so ours is far less steep. So the equation for the green line is 0.25 x plus 2 squared because it has gone up 1, whereas without the multiplier it will have gone up 4. All this relies on you being 100% being able to sketch a parabola, of course, and so if you can't do that, there's no point really attempting to do this skill. So to recap, you take the general form of the parabola, you compare the height at some point, y-intercept or turning point, what it would be without the multiplier, and then the multiplier is what the multiplier is, what we actually see as the turning point or intercept, over what it would be without that multiplier.